Determine all critical numbers for the function f of x equals x plus sine of x. Critical numbers are the x values that make the numerator and the denominator of the derivative equal to 0 and are in the domain of the function. The first thing to do is find the domain. F of x equals x plus sine of x is made up of two terms, x, a polynomial, whose domain is all reals, and sine of x, whose domain is also all reals. So the domain here will be all real numbers or negative infinity to positive infinity. The next thing to do is find the derivative. F prime of x equals first term, constant times x, derivative will be the constant. Derivative of sine is cosine. We now set the numerator equal to 0, and the denominator, if there's one, also equal to 0. Subtracting 1 from both sides, cosine of x equals to negative 1. And we want to think of all places where the cosine is negative 1. This happens at pi. It will happen again at 3 pi and at 5 pi. So it'll happen at negative pi, negative 3 pi, and negative 5 pi, and on and on. There's an infinite number of places where this occurs, on and on here as well. So there's an infinite number of possibilities here, but these can be put together into one statement. Each one of these is an odd integer times pi. One way to make an odd integer is the statement of 2n plus 1, where n is any integer. If you multiply it by 2, it becomes even. If you add 1 to it, it will always be odd. 2n plus 1 times pi, where n equals any integer. If n is a 0, that'll make 1 pi. If n is a 1, it'll make 3 pi. If n is a 2, it'll make 5 pi. But n can also be negative. If it's negative 1, it'll make negative pi. If it's negative 2, it'll make negative 3 pi, and so on. So all these are included in the statement. The next thing to do is make sure whether they are in the domain. The domain here is all reals. 2n plus 1 times pi, for n being an integer, is always a real number. All of these are included and kept. And they're all critical numbers. So we've determined all the critical numbers for the function. And it's x equals 2n plus 1 times pi, where n is any integer.